Yes, sir.
Okay, so we'll start with just the brief of what we have learned yesterday. Okay, so on yesterday's lecture, what we seen over there, it is like types of polymerization, or we can say it as a how your polymer made using different types of polymerization methods. Okay, in that we have seen we have seen two types over there. Okay, means at the start of the lecture we have started with two types of methods, like addition polymerization, and second is your condensation polymerization. Okay, so in condensation we have seen three examples over there, how condensation polymerization which polymers are getting polymerized using condensation polymerization. Okay, at the start we have seen three examples. Can you tell me which all three examples we have seen yesterday for condensation polymerization? Hello, hello, hello.
Hello.
Yeah,
Condition, we talk about the step growth.
yeah, which we can call it as a step growth. Then
And
means we have to three examples or three polymeric materials synthesis using condensation polymerization. Okay,
yep,
so I think one of that example is like your polyester. Okay, we have seen how polyester gets synthesized using your condensation polymerization. Have we seen yesterday?
yeah, polyester,
Yeah, yeah.
polyamide,
Then which others are there?
polyamide,
Yeah, polyamide. Then again, polyurethane. Okay, these
yeah,
three examples we have seen using your condensation polymerization. Okay, then which one the sequence type we have studied yesterday, which is like addition polymerization. Correct?
correct.
Yeah. In addition as well, then again three types we have seen, which are like free radical polymerization, cationic polymerization, and anionic polymerization. Okay, in which also I think three steps are there. Which three steps are there? It is like a start of your polymerization, which we called it as a initiation. Then second, hello, yeah, first is like initiation of your polymerization. Second is like propagation, and third is termination of your polymeric chain or polymerization. Correct? Hello.
Correct, correct, correct.
Yeah. So these types or these methods of polymerization we have seen yesterday. Okay. So out of which we have take many of the example of polymeric materials synthesized using these different methods. Okay. So as of now, whatever we have learned, now we are moving forward for the polymerization techniques. Okay. So here, as you have seen on the screen, again polymerization techniques or polymerization process are divided into two major types. Okay. One of them is like homogeneous polymerization, and second is like heterogeneous polymerization. Okay. So one by one we will take. Okay. First of all, homogeneous or we can say homogeneous polymerization. Okay. What happen in homogeneous polymerization is whatever we are going to synthesize is in your single phase only. Do you know about phase, or we can say state, or like suppose example of homogeneous phase we can take it as a, like suppose we have one container with water. Okay, so we can consider one container with water, and if you add sugar or we can say salt in it. Okay, so what will happen if you have take one container in which water is there and we are going to add salt in it, what will happen?
It will dissolve.
Yeah, it will dissolve. Then we cannot say like that it is a like that liquid is in a single phase. Like you can't say like two things are there, water and salt. You can't see by naked eyes. Okay, so that system you get as a homogeneous system. That system is called as a homogeneous system. Okay, so similarly, the type itself suggests that the system or the polymerization type in which all of your components are in a single phase. Okay, so that type of polymerization is called as a homogeneous polymerization. Okay, means whatever what all requirements are there for polymerization. It is a monomer initiator. Okay, you require monomers. Then to initiate the polymerization reaction, you require initiator, correct? As we seen yesterday, correct or not? Hello?
Yeah. Thank
Yeah,
you.
yeah. So we require monomer initiator and at last chain transfer agent or chain termination agent. Okay. These three things majorly we require for polymerization. So in homogeneous polymerization, all of these three things are in a single phase. Okay. That if that three things are in a single phase, then we can call it as a homogeneous polymerization. Okay. Second is like heterogeneous polymerization. It is nothing but name itself suggests us. It's like if suppose again we can take example. If suppose same container we are taking water, okay, and in that water suppose we are taking some soil, okay. So can that soil dissolve in your water? Hello, hello,
Yeah.
hello. Yeah. So if
It
I
will
take
dissolve.
yeah, what,
It will dissolve that water soil.
that soil,
Yeah.
or we can say sand.
Yeah. Sand or soil. Yeah.
Sand will dissolve in water.
Yeah. It means dissolve means it will mix, but
Yeah, but will not dissolve in water, correct? So if you
yeah,
see by
kind of.
your eyes, the sand will be, you can see the soil or sorry, you can see the sand in your water, okay? And water is means water and soil in a separated form, correct? Means you can observe sand over your water, correct? So that thing is not miscible, correct? So the system like that we called it as a heterogeneous system. Okay, hello.
Yes, sir. Yeah, yeah.
Yes. So whichever the system which is having single phase, we called it as a homogeneous, and which are having multiple phase, it is called we called it as a heterogeneous phase. Okay, or we can say it call it as a heterogeneous system. Okay. So again, you can see here homogeneous polymerization divided into two types. Okay, one is like bulk polymerization and second is like solution polymerization. One by one, we will see these polymerization techniques in detail, or these polymerization processes are in detail. We'll see. Okay. First of all, you just have to know about what all kind of polymerization processes are there. Okay. So in heterogeneous polymerization, again, two types are there. Okay. One is suspension polymerization. Second is emulsion polymerization. Okay. Have you understand about the types? Hello.
Yes, sir. It's
Hello.
clear.
Yeah. So you can note down these things. Okay. Like type, first of all, type of polymerization processes that divided into two types. First is like homogeneous polymerization. Second is heterogeneous polymerization. Again, these both polymerization processes are divided into two sub types, like homogeneous polymerization divided into bulk polymerization and solution polymerization. Heterogeneous polymerization divided into suspension and emulsion. Okay. So one by one we will look on it. Here you can see polymerization techniques, okay, which are like these four as we seen in last slide. Okay. So first we will go through bulk polymerization in detail. Okay. So what is bulk polymerization? Or we can call it as a mass polymerization. Bulk polymerization is also called as a mass polymerization. So what will happen in bulk polymerization? Okay. So this is one of the simplest technique which generally used for polymerization of your polymer, means to made a polymer. This is one of the simplest technique. So what will happen in this technique? So just consider you are having monomer, initiator and terminating, or you can say chain transfer agent with you. Okay. Just imagine the things you are having monomer and initiator with you. Okay. So what is the requirement of it? Like if you want to synthesis some polymer, or if you want to make some polymer, you will just have to mix the monomer and initiator. And as per its requirement, if you want to means some polymerization wants heating, some polymerization wants some stirring over it, means the mixing. Okay. So if you apply the same, you will get polymer out of it by reacting monomer with each other. Okay. So the system which consists only your monomer and initiator, okay, that, and out of which we form the polymer, that called as a bulk polymerization. Have you understand? Hello, hello.
Sir, can you give me an example?
Are you getting my points, or having some doubts?
Yes, I have doubt. Can you give some example like before?
Okay, okay. We will take one example. It is like suppose like we are having, like as per the yesterday's lecture, if we synthesis one polyester, okay. So if you want to synthesis polyester, then what all raw materials or what all monomers we can take for polyester? One is your diol, which is having two hydroxyl functionalities its end, and one is diacid, which is having two acid functionalities on its ends. Correct? Hello, hello.
Yes, sir. Yes, sir.
Yeah. So that two things we will mixed with each other. If some initiator is required or some catalyst is required, we will mix that catalyst or initiator with them. Okay. That thing we will react with each other without presence of any solvent. Okay. Without presence of any solvent or any other material. Only your monomers and initiators thing will be there. Then that polymerization called as a bulk polymerization. Means the whatever
Oh,
product we get out of it is only polymer. Okay. Only polymer, the product in form of polymer we will get. Okay. Have you understand? Hello.
okay.
Okay. So you can see here the points: only monomer, a monomer soluble initiator, and perhaps a chain transfer agent are required. When we use chain transfer agent at the last of your polymerization to stop the polymerization process. Correct. This process can be used for many free radical polymerization and some step growth condensation polymerization. Okay. So here in image you can see like what all requirements of bulk polymerization is: monomer and initiator. If you can able to see in this image, okay, one reactor is there. This is nothing but a reactor. Okay, or we can call it as a vessel, or any pot you can consider, in which we are synthesizing polymer. Okay. So in that, if you add monomer and initiator, okay, monomer, initiator, and hello, hello, hello. Am I audible to all of you? Hello, 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 hello.
Hello.
Yeah, am I audible?
Yes, sir. Tejas, Kalanidhi, Aslam sir, please reply. Arvind Kumar, I don't know why they have not replied.
Uh, Actually, I'm seeing them, their activity. Okay, so yeah, audible. Someone have messaged. Okay, so in bulk polymerization, the requirement is only like that. You are requiring monomer initiator. Okay, out of that you will form polymer in form of bulk, or you can say mass or a single mass form polymer will get out of it. Okay, so what all benefits of the bulk polymerization are there? Okay, so if you see, like, all advantages of bulk polymerization, high yield per reactor volume means we will get only the polymeric form product over it in a bulk form. Okay, so means whatever we will get is consist of only polymer. Okay, it is easy to recover the synthesized polymer. This is the nothing but second advantage of your bulk polymerization. Then third is like the option of casting the polymerization mixture into final product form. Like whatever the mass we will get, we can able to cast the mass of the polymeric material, whatever shape or whatever thing we can. Okay, some there are limitations of your bulk polymerization. Okay, the limitations are like if you have bulk if you synthesizing the polymer using bulk polymerization, so in that you can't control the molecular weight of your polymer. Okay, as you are having only monomer and initiator in your reacting system. Okay, your whatever available monomers are there are form polymer very rapidly. Okay, there is no control of molecular weight. Okay, hello, 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 hello. Okay, if you can hear me, so at least respond. Okay, respond by talking. Okay, so that we can proceed forward. Okay, so bulk polymerization, like limitations of bulk polymerization are like we can get higher molecular weight products. That molecular weight of your polymer we can't control. Okay, it's difficult to control the molecular weight of your polymer. The problem of dissipating heat produces during the polymerization, as you know that, like, in bulk polymerization we can't control the molecular weight. Your monomers will get react very fastly with each other, so it generate heat, or we can say the reaction will get exotherm. Okay, so in that case heat dissipation is there during bulk polymerization. Okay, so there is difficulty to remove, like if you are using this technique, so you will get polymer over it, but it is difficult to remove unreacted monomer out of it. Okay, these all are the limitations of your bulk polymerization. So next is like, as this means, as you know, we divided this type into your homogeneous system. So why it is homogeneous? Because your polymer and because your monomer and initiators are in a single phase. Your initiator should be like monomer soluble, as it is we have mentioned here. See, in third point, only a monomer soluble initiator and chain transfer agent is required. So all of these are in a single phase. That's why we called it as a homogeneous polymerization technique. Okay. Hello. 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 Okay, so we'll move forward for next polymerization technique. Okay, which is nothing but like solution polymerization. Okay, name itself suggests us like solution. What do you mean by solution? Hello, anyone know about the what one can explain like what is solution? Hello.
Is a mixture of solvent
Yes.
and solute.
Yes. 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 Solvent and yeah, you are telling correct things. Can you
Yeah,
repeat again?
I forget that word.
What?
For example, water and salt.
Yeah. For example, water and salt, as you telling the example, water, if you mix what salt in water, so we will get the solution of your salt, or we can call it as a salt solution, correct? So in that, which solvent you have used? Water as a solvent. Okay. So in that you have used water as a solvent and your whatever you have salt used, that salt as a solute. Correct. So out of which if you mix the solute in your solvent, we will get the solution. Correct. Okay. So similarly, we can relate that thing here also. Here the type is like solution polymerization. Solution polymerization is nothing but like your monomer and initiator. We will dissolve in one of the solvent. Okay, correct. The monomers and your initiators, we will dissolve it in a solvent. Okay, and we will form a solution out of it. Okay, and in that solution or in that solution form, your initiator will start your polymerization process with the help of monomer, and it will form long chain to synthesize a polymer. Okay, in solution form only. Means whatever solution you have prepared, in that solution only your polymerization will get start and polymer will get formed. Okay, the whatever product you will get, it is in a liquid form. Means you will get your polymer in liquid form, which is dissolved in your solvent. Correct. Hello. Hello. Hello.
Yes, sir, you may proceed.
Yeah. So whatever polymer you will get out of this is in the form of liquid, or you can call it as a in a solution form. Okay. So what what exactly the benefits or what happened in solution polymerization is like heat removed during the polymerization can be facilitated by conducting the polymerization in an organic solvent or water. Means what is the drawback of your bulk polymerization majorly is dissipation of heat or generation of heat, you can tell it as a like during bulk polymerization, as it is having only means monomers and initiators. Okay, so there is no media over it, but in solution polymerization we are having solvent. Correct. So due to presence of solvent, if during the polymerization heat is generated, that heat will dissipate or that heat will be ignored or covered by your solvent. Okay, your solvent will dissipate that heat. Okay, have you understand that?
Yes, sir.
Yeah, because as your polymerization will start, as your molecular weight of your polymerization will get build up, means more and more monomers will get react, your polymer will form. Correct. In that, if heat is generated, that heat will be we can say neglect in presence of your solvent, correct? If suppose water is solvent, I'm just taking the example, okay? Not don't consider it as a permanent solvent as a water. But if water is there, suppose in water some polymerization you are carrying out, okay? If heat is generated in between, so your water will cool down it, correct? Yes. So your water as a solvent or anything as a solvent, whatever you are using for polymerization, that solvent will cool down or that will control your heat produced during your polymerization. Okay. This is the main benefit of solution polymerization. Okay. In this, both the things like initiator and monomer have to be soluble in your solvent. Okay. Then only this reaction can be possible. This is the requirement of your solution polymerization. Okay. Third is like the solvent have acceptable chain transfer characteristics and suitable melting and boiling points for the condition of the polymerization and subsequent solvent removal step. It is nothing but solvent should have like a specific boiling point if you want to remove the polymer out of it. Okay. Suppose you are having a solution of polymer after polymerization. Okay. After polymerizing any of the polymer using this technique, your polymer will be in the form of solution, correct? So if you want to recover polymer out of it, then you should remove the solvent. Yes?
Yes.
Yeah, after removing the solvent only you will get the polymer. So to remove the solvent, we have to evaporate the solvent, correct? After evaporating, we will get the polymer. Okay? So solvent choice should be accordingly the boiling point of its or its boiling point temperature. Okay. The reactors are usually stainless steel or glass lined. We can whatever reactor or the pot we are using for synthesizing the synthesizing solution polymer using solution polymerization. It is made up of stainless steel or glass. Okay. Yeah, here you can see the image for solution polymerization. Okay. What all requirements are there for solution polymerization? Can you tell? Hello.
It's
So list monomer, all those things, no? Initiator
Yeah.
and
So as we have seen earlier, in bulk polymerization, only monomer and initiator are required to synthesize the polymer. Correct? Now you can differentiate between the methods. Okay. In solution polymerization, what extra things are there? Solvent. Okay. In this solvent, we require to control the molecular weight and to control the heat of the reaction.
the catalyst is another one, no?
Yeah, catalyst is nothing but here use it as a initiator. Okay, it is mentioned in that sense only. Okay.
Either of these two, catalyst or initiator can be used.
Yes, 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 correct. Okay, so only solvent is the extra thing in solution polymerization. Okay, why solvent is there?
To dissipate the heat.
Yeah, to dissipate the heat. Whatever heat will generate during the polymerization, to dissipate or to control the heat of the reaction, solvent is there. And again, to control the molecular weight, whatever molecular weight it will form. Okay. So whatever polymer you will get, it will be in solution form. Okay.
But it will not get dried, huh?
Yeah, it will get dried, but afterwards, whenever you want polymer out of it, okay. If you
Then
are having polymer solution with you, okay. So if you
as
want,
as it dries, the density will also change, huh?
yes, yes, yes. Means after this solution, after removing of the solvent from this product, you will get only polymer. Okay. So polymer you will get that polymer's density is different than your solution density.
Okay.
Okay. Yes. So that in that way you can extract your polymer from that solution. Have you understand?
Yeah, yes.
Yeah, correct. So Again, there are some points related to solution polymerization that main benefits over bulk polymerization is, as we have discussed, it will control your heat and molecular weight and formation of polymer, means that speed of polymerization. Okay, these are the main benefits. Okay, so let's move forward for our third type.
Sir,
Okay.
molecular weight means how a molecular weight can get improved? Then it will have water atom into that. Because of
No,
that,
no,
it
no, no, no.
molecular weight is
I'm
increased.
I'm 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 not saying like that. See, if you use same number of monomer, okay, suppose for example, just take an example, okay. B- Uh, we are using these two polymerization techniques separately for same monomer, okay. Suppose
Okay.
if you are taking like 100 monomers of ethylene or whatever polyethylene, as you know, okay, polyethylene, you know, correct. So
Yeah.
if you take 100 monomers of ethylene for solution polymerization and 100 monomers of ethylene for bulk polymerization, correct? We
Okay.
are producing polymer via both techniques. Okay, but in what happen in bulk polymerization, your monomers will get react fast in presence of your initiator. Okay, as it is only having two things in your reaction system. One is monomer and one is initiator. Correct. So your monomers will get add rapidly. So it will form high molecular weight products, as it is speed is more and it will form rapid polymerization. Correct. And similarly, if you see in solution polymerization, monomer and whatever initiator, they both are dissolved in your solvent. Correct.
Okay.
Okay. So many there are spacing between number of monomers in your solvent, correct, because it are dissolved, means if you imagine, like if you have dissolved something in water, then there are some space between two or three particles, correct.
Yeah, yes.
Yeah, in similar way, if you dissolve some monomer and initiator into this system, solvent system, so in that your monomers are separated by the solvent, correct? So as you start the polymerization using initiator, your monomers will get react one by one, not that much of speed as compared to your bulk polymerization. Okay, so that molecular weight buildup or attaching of your monomer is somewhat in control, correct. So rapidness is not there as compared
Okay.
to bulk polymerization. Okay, that's why we can say like polymerization or molecular weight we can control, or we can at least the speed of polymerization is less than your bulk polymerization. Okay.
Okay.
Okay, these two or three major differences are there between bulk and solution polymerization.
Meaning in between the gaps of molecules,
Yes.
this catalyst and these things will come, but it will get like sticky items, like it will get
Yeah. Over
like
as your polymerization proceeds, the
uh,
solution will get means that viscosity of your solution get increasing. Okay,
okay.
that solution viscosity will get increased. So it is the only sign by which we can consider as a polymerization is happening. Correct. So at the end, after reacting your 100 monomers, your solution will be in form of viscous liquid. Correct.
Okay.
Out of that viscous liquid, if you evaporate the solvent, okay, you will get the mass of your polyethylene.
So after drying, even after drying, this monomer weight will retain. Weight means this molecular weight.
Yeah, means that molecular weight is in whatever the polymer will get formed. You will get that polymer after evaporating the solvent. You will get the polymer in mass form.
The
Okay.
solvent will be in the form of some settlements over the
No,
molecules.
no, no, no. It is depend upon again if that in solvent, if your polymer is get dissolved. Okay, your polymer is dissolved in your solvent, so that solution is there. If you evaporate, like as you said, the example of salt in water. Okay, can you look or can you observe the salt in water? Like, can you see the particles of salt? Because you can't see, because that salt is completely dissolved in your water. When you will see it, if you evaporate all of your water, okay, then at the base you will observe the crystals of your, or particles of your salt, correct?
Okay.
In the similar way, here also, after evaporating the solvent, you will get the mass of your polymer, or
Okay.
polymer in the mass form.
Okay.
Okay.
Okay, sir.
Yes. So these are the two basic types of your polymerization techniques. Okay. Next technique to the types of polymerization is nothing but your suspension polymerization. Okay. Do you know what is mean by suspension?
Elimination.
What? Yes.
Is there any all this polymerization? Is there any base that this polymerization for same polystyrene? It is for sari purpose or some, so where there is a flexibility is required. Like that, can you explain us so that we can understand and relate with practical things?
Yeah. Practically, that's why I'm telling. See, whatever the polymerization techniques are, I am explaining today to you. Okay. We will take a single example, like if you are taking some like, as you mentioned over here, polystyrene or whatever it is. Suppose if you take one single example, so how you will get different types of in different form, means polymer in different form out of it, that we will see. Okay. So as I said, like in bulk polymerization, nothing except your monomer and initiator is there, correct? Only monomer and initiator is there, correct? Nothing is there. So your polymer you will get in a bulk form, or you can say a single mass. Okay.
It's like it is again additional polymer only, no?
Yeah, addition polymer. you
So it is
can you can you can consider it as a addition as well as your condensation polymerization, whatever it is. But in that, only your monomers and initiator should be there.
okay.
Okay.
It can be a patterned or it this thing also by pattern or something that you told, no? Anything is accepted. Huh? Alternate pattern and that.
Yeah. Anything is accepted. Correct. As you said, it is not having some perfect pattern like A B A B A B in that way. Okay.
So pattern can be anything. Oh,
Yeah. Pattern can be anything. Correct. So in first we will get the polymer in mass form. Okay. In second we will get the polymer in solution form in which solvent is present. Correct. Okay.
the end application can both can be used for the same end application. Huh?
Yeah. That's we will see after explaining four of the this four, all four techniques.
Okay, understood. Understood. Okay.
Okay. So that's why you will better understand it at last after explaining these two type of remaining polymerization techniques. Correct.
Okay. Sir.
So let's come to this type like suspension polymerization. What the word suspension mean for? Like, what can you say about the suspension? Can you?
It's like one medium is floating in another medium continuously and not getting
Yeah, means suppose
separated.
if you consider water and oil, okay, or you can say you are having water in one container, okay, and some oil droplets over it. So oil will be at the surface of water or at the bottom of water? What do you
It's
think?
surface.
Why it is so?
Its density is less than water.
Yeah, it is density is less than water. So in similar way, for suspension means that word only, we will take a simple example. Okay. So if you have water in a container, okay, and you are going to add oil in it, okay, suppose half of the container is filled up of your water, and some amount of oil will be added in it. Okay. So you will see the see two layers, correct? First layer is of your, this upper first layer is of your oil, correct? And the second layer is of your water. Okay.
Yes.
Yes. if you try to mix the two things, what will happen?
Temporarily, it will get mixed and again it will go to its original this thing. Oil will go to the top and water will come to the bottom.
Yeah, after settling down, correct? So
Hmm.
but during the mixing, what you can observe over there, it will get mixed, as you said. Okay, but what the thing is there, it is not getting mixed actually. Your oil will form some droplets in between your water, correct? That's
Yeah.
why you can observe a hazy solution, correct? That
Yeah.
hazy solution is nothing but suspension of your oil droplets in your water.
Okay.
Okay, that thing we called it as a suspension. Okay,
Meaning
I'm
this
yes,
is a temporary phase.
yeah, this is temporary phase. Okay, it is I'm means primarily I'm taking the example to elaborate the suspension part. Okay,
Okay.
so as I am again repeating that if you are taking water, okay, in water you are taking some amount of oil and you are trying to mix it. Okay, your what both the things will not get mixed, but while mixing you will see the droplets of oil in your water system. Okay, that is nothing but your suspension. Okay, so in similar way we will use this concept for polymerization. Okay, so how we can use the suspension concept in your polymerization, we'll see.
So
Okay,
we can call it as a partial.
yes,
Can we call like your partial viscous?
partially.
Water is mixed
Your
with oil, it's getting some droplets.
hello, can you repeat? Your voice is not clear. Hello, hello, hello. Okay, can we call it as a partial mix? Yeah, so we can call it as a partial mix. It is not a partial mix. It your water and oil will not get mixed. Okay, it is just a suspended, like your oil droplets will be suspended in your water. Okay, it we can't call it as a mixture. Okay, we can't call it as a mixture or partial mixture. We can't call it as a mix, but we can call it as a mixture of like your oil in your water, but not in a completely mixed form. It is in a suspended form. Okay.
Yes,
Yes.
sir.
So yeah. Okay. So the next part is like we will use that suspension concept for your polymerization technique, which is third polymerization technique. Okay. So in that, what will happen? We'll just understand this thing. We will take a water. Okay. Water as a liquid phase. Okay. Usually we take water. Okay. Instead of water, you can take like but for the first example, we will take it as a water. Okay. So in water, we will take a monomer. Okay. Monomer will be water insoluble. Monomer should be water insoluble. Okay. In this type of polymerization. So if you add water insoluble monomer in water, so you will again get suspension media. Correct. Again you will get suspension over there. Okay, suspension of your monomers in your water system, correct? And
Yes.
yes, again we will take initiator which is soluble in your monomer. Okay, means initiators are also suspended in water with monomers, correct? These three things are there: water, monomer and initiator, correct?
Yeah, yes.
Okay, so out of it, two, like as you said earlier, like if you stop the stirring or if you stop the mixing, that phases will get separate. Means water will get down and your oil phase will get at upside. Correct. So that suspension will break, or you can say separated. Correct. So to
Hmm.
maintain the droplets, okay, to maintain the droplets in your suspension form, so what we add is called as a surfactant. Okay. What?
Yes.
Surfactant. Surfactant is nothing but your, or we can call it as a emulsifier, but here we can call it as a surfactant. Okay. So we will add surfactant to it. So by adding the surfactant, your droplets will get separated, or not separated, but your droplets will get stable in your water medium. Okay. Means whatever, if you stop the mixing, after mixing as well, your droplet, you can see your droplets in your water, means monomer droplets in your water. Can you
Meaning that
imagine that?
it get suspended, it will be flying inside the medium.
Yeah. It will be suspended, or you can say it will be inside the medium, but in a droplet form.
It can get, okay, if even if it is already, it will get suspended, no, normally. If it is an
Normally what will happen, if oil and water is there, correct?
Hmm.
Correct. Suppose half of the glass you have taken oil and half of the glass of water. If you continuously mix it, so during the mixing, it will form droplets. But if you put it for some time, okay, it will get separated, correct?
Yeah, without an without this thing,
Agitation or mixing, it will get
uh,
separated.
emulsifier, without emulsifier, it will get
Yeah,
separate.
without emulsifier, it will get separated. But
But
with emulsifier, the droplets are in stable form, correct?
what is the stable, that is what?
Stable means that are, you can look like that droplets will not break and will not, that two layers will not get separated, whatever oil and water layers are.
So it will retain in the same this thing. Then
Yes. It will retain the same droplet form in your water.
the emulsifier is acting on the density of that particular monomer.
Yeah, now correct. So what is emulsifier actually? What is structure of emulsifier? Okay, that we will study here. Okay, can you see? I will try to draw. Okay, first of all, can you observe the thing?
Yeah, yes.
Okay, one chain is there, chain like structure, and one head is there over it at the chain. Okay, so in this case, what will happen? Okay, so this is nothing but your emulsifier, or we can say surfactant structure. Okay, both the things are same. So your emulsifier having the structure like one of its end is hydrophilic and one end is hydrophobic. Okay, so have you know the concepts of hydrophilic and hydrophobic? Yeah, I will explain that. Just want to know, like, have you know the concept of hydrophilic and hydrophobic?
No, no, sir. We are hearing for the first time.
Okay, you are listening this first time, correct?
Yeah,
So
it's like more of water, water soluble like that, hydrophobic, or it is
okay,
water relation. It is having some relation with water, hydrophobic.
it is having some relation with water as well as oil. Okay, so let's talk about some hydrophilic and hydrophobic part. Okay, so hydrophilic. Okay, first of all we will take hydrophilic. Okay, hydro means water. Okay, philic means loving. Water loving means nothing but the part which tends to dissolve in water, or which likely to dissolve, or which likes water part. Okay, which is called as your hydrophilic. Okay, this head structure, I have represented it in a simplest form. Okay, the chemical structure is again different. Okay, we will not see the chemicals, exact chemical structure, but for your understanding, this representation is there. Whatever head you are looking here, correct? Can you able to look this head?
Yeah, yes, sir.
Okay,
Circle.
so this head is called as a hydrophilic. Hydrophilic is nothing but the term we can call this as a water loving. Okay, means which tends to get towards water part.
Okay, it's attracted towards water.
Yeah, it's attracted towards more towards water. Okay, and hydrophobic. Hydrophobic is nothing but your water repellency. Means water repellency. Repellency means it is not a water loving part. So what it will be? It will be oil loving. Correct. So it tends to move towards oil.
Okay.
Okay. Yeah. So have you cleared about it? This is the simplest.
Hydrophilic and hydrophobic.
Yes, hydrophilic means your water loving. Correct. Or you can say tends towards water.
Okay.
Okay. And hydrophobic is nothing but your
Oil. Tends towards oil.
yeah, tends towards oil. This is the simplest concept behind it, behind hydrophilic and hydrophobic. Correct. So if you add this thing in your water and oil emulsion, or sorry, water and oil suspension, correct. So what will happen? How this structure will act?
Both will try to stretch.
We can't say like both will try to stretch, but we can say like this part, which is called as a hydrophilic, it will be move towards your water side, correct?
Okay.
As it is water loving, and this part, whatever we call this at a hydrophobic, it will move towards or tends or directed towards your oil part.
Okay. Then it will
Correct.
form precipitation form type.
No, not precipitation. Your oil and water, it will, because if you add this, it will retain your both parts, oil as well as water. Means it will handle the both parts. It will not.
Okay.
It will not supposed to separate that both.
So it is not acting like
This
a
thing will bind your both parts. In short, you can say bind.
binding. It is binding these two and not reducing the density of
Yes.
a higher
Yes.
molecule. It is only creating a binding between these two.
Yeah, binding. It can act as a binding thing. Not exactly binding, but physically you can assume.
Okay, understood.
Okay, understood? So
Yes.
it will bind your water as well as oil sides. Okay, so that's why your oil and water will not get separated. Correct?
Understood, sir.
Correct. Surfactant is nothing but if you observe, like as a washing thing, like cloth washing, we are using some surf excel like material, or we can call it as a what we call
Detergent.
it as a detergents. Correct. So we are using that part for cleaning purpose. Okay, so why we are using for that, like surfactant we are using for cleaning, because if you are having some oil part in your clothes, or oily thing if you spill on your clothes, so if you use surfactant over there, or you can say detergent over there, so your oil part will get removed. Correct. Why it is so? Due to the effect of your surfactant, because your surfactant having structure like this, one is like hydrophilic and one is hydrophobic. So the hydrophobic part will remove your oil part from your clothes, and your whatever hydrophilic like water like that will wash your clothes. Correct. Yes. Hello.
Yes, sir.
Yeah. So this is nothing but the simplest mechanism of your surfactant. So same thing we are utilizing in your suspension polymerization. Okay. What will happen in suspension polymerization? We are using monomer, initiator, water, and surfactant, or we can call this as a emulsifier. Okay. So here you can look the examples. Okay. What all things are required? This is a water system. Can you observe this? The bluish. Hello. Hello.
Yeah, yes, sir.
Yeah. So this is nothing but your water system. Okay. and if you can observe here, green and these blue droplets are there, correct? These droplets are nothing but your monomer droplets with initiator in it, correct?
Okay.
Okay. So by zooming it, we can observe here two droplets, okay, which are surrounded by your surfactant. Can you observe here surfactant molecules
Yeah,
or
yes.
surfactant structure? So whatever the end of this surfactant are tends towards your water.
Okay.
And the head, you can say tail of the surfactant is towards your monomer droplet. Okay. So according to that, your droplets stabilized in your suspension system. Okay.
But still there will be some suspension. But the suspension will not be fully. It's like that, or completely suspension will not be there.
Yeah, after managing the concentration of your surfactant, okay, whenever means it is again dependent on your surfactant concentration. Okay, there are formulations set for your polymerization, means suspension polymerization techniques, in which specific amount of surfactants have been used to stabilize this kind of solutions. Okay, in that case, perfect suspension you will get.
Okay.
Okay, here you can observe the perfect solution over here. Okay, so this is nothing but suspended system or suspension system. Okay, so how polymers will get form out of it, that we will see now. Okay,
Okay.
have you understand about suspension?
Yeah, yes, sir.
Yeah, correct. So now we will form polymer out of it. Okay, so have you observed here two droplets? Okay, so these two droplets are nothing but your monomers and initiator inside it, correct? Okay,
So if the outer is the emulsifier
yeah,
and say
emulsifier.
color is water, green color is
Yeah, means these green droplets, or you can say blue droplets, if you are using,
monomers.
suppose in this case, we are using two types of monomers.
Okay. So
Okay,
here
one is like green and one is this dark blue.
blue, but you told oil and water. So where is the oil here?
Yeah, that's why I told you in last slide. In this water, we take it as a medium. Okay, this whole medium is
And
water, correct? Okay, and
okay.
we are taking water insoluble monomers.
Okay.
Okay, that water insoluble monomers we can consider here as a oil droplet. As it is insoluble in water, we can consider it as a oil droplet. That's why I just took the example of oil in water. Don't take it for further understanding. It is just to understand your suspension part. But
Understood.
yeah, for polymerization, in water your monomers are there, water insoluble monomers. Okay, this is nothing but your monomeric droplet, correct?
Okay. Understood. Understood.
Okay, so we can now learn about the how polymerization will happen in this system. So this is nothing but your monomeric droplet. So if suppose in one droplet 50 to 100 monomers are there, okay, in single droplet. Okay, so that monomers in presence of initiator, as we mentioned here, initiator is monomer soluble. So if suppose your initiation will start from this side, your polymer will get formed, like more and more monomers will get add, and you will form a polymeric chain, or you can say polymer over it, correct? Hello, 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 hello.
Yes, sir.
Yeah, am I audible now?
Yes, sir.
Yeah, so in this droplet we will get the polymer. Okay, polymer synthesized using your monomer and initiator. Okay, so in this way we will get the polymer in form of beads. Do you know the beads? Hello.
Yes, sir.
Yeah.
No, no. What is
Hello.
beats?
Beads are nothing but if you can see, like suppose you have sugar, or you can say sugar balls, small sugar balls, or you can take example nothing but like Have you seen any polymer or a raw material of raw polymer?
Is it like glass fill item?
No, no,
No,
it's
no,
not like a
it is
glass
like
field.
pearls, जो मोती
Yeah,
होते हैं ना
pearls.
वैसा.
Have you seen the pearls?
Yeah, yes.
Yeah, it is like a pearl structure. Okay.
Then why should that be added here? Beads.
Yeah, because in case of polymers, we called it as a beads.
It like fillers, huh? It is like fillers, huh?
No, 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 not like filler. I will show you the figure. Okay. If it is available there or not, I don't know. But polymeric beads, or you can simply like pearls, or you can whatever pearls. Have you know the small pearls?
The pearls I know, pearls and all, it's normally available in market. We understand
Yeah,
it.
yeah, yeah.
But
In that form, you will get your polymer
okay,
from
right.
this suspension polymerization. That
Okay.
pearls are nothing but you can call it as a beads in case of polymers. Okay.
Beads are the output of suspension polymer, huh?
Yes, output means you will get the polymer in form of beads.
Okay.
Okay. As we've seen before, in bulk polymerization, you will get the polymer in form of bulk or a single mass. Correct?
Yeah, yes.
In this polymerization technique, suspension polymerization techniques, you will get the polymer in beads form, or you can say that pearls form. Correct?
Okay.
Yeah. So this is the main advantage of this suspension polymerization, because after your polymer getting polymerized, you will get beads from this solution. Okay, whatever solution water is there, you will get directly pearls like polymeric, means that small units out of it. Okay, that you
So
can collect directly.
here green color is getting captured by the emulsifier and it is creating that. What
Yeah,
about the
it is only the representation. It is not exactly green. It is
okay.
just to understand you. We have
No,
like,
that is one monomer. So A monomer it is taking and emulsifier is acting on
yeah,
it.
monomers means it is a
Come,
bunch of monomer you can consider.
what about B monomer, blue color?
Yeah, that's I am telling. Here green color is nothing but bunch of monomer.
No, no. That is there are two types of monomer inside that
Yeah,
you said blue and green color
yes,
are different monomers.
yes.
So when emulsifier is reacting, water is a common thing, but in the space
See, here, see, one thing is there. Emulsifier is not reacting with anything.
it is only capture.
Yeah,
Yeah,
it is only maintaining your suspension.
yeah, yes.
Yes, it
But
is not reacting.
it will also that same emulsifier will work with blue
Yeah,
color.
it is again as I have mentioned, there are different formulation or set of formulations. Okay, here only I am taking some example like to understanding of your emulsion polymerization. Okay, it is not exactly like only one emulsifier will okay for all polymers or all monomers. Okay, it may be different.
So
Okay,
in this case, it is compatible with this both monomer, and
yes,
both the monomer it is trying to bind with the water with some
yeah,
distance.
it's not a bind but physically binding, you can say.
Okay.
Okay, so you will get your suspension. Correct. So what is the basic thing in suspension polymerization is, what are the requirements? Water. See, the basic requirements are same. Monomer,
Water
initiator.
monomer emulsifier.
Okay, monomer, initiator is the basic requirement for all polymerization techniques. That is same here. Then emulsifier and water are the additional requirement for your suspension polymerization. Okay,
Sir, in place of emulsifier, you used another word. What is that word?
that is surfactant.
Yes. Can you spell it?
Surfactant, I will write in your chat box. Okay,
Okay.
you got it.
Okay, sir.
Okay, so this is nothing but surfactant or emulsifier. Okay, so this is nothing but your suspension polymerization. So what product we will get, or what kind of product we will get from suspension polymerization is in the form of beads. Okay, So what happen? How this polymerization is different than your solution and bulk polymerization? Okay, as you know, you will get the polymer in mass form in your bulk polymerization, in solution form in your solution polymerization, here in beads form. So what is the difference? Like if this droplet, okay, this droplet contains specific number of monomers, okay. Suppose I will consider here 100 number of monomers are present in this droplet, okay. So only we will get the polymeric chain with 100 repeating units, not more than that, correct? Hello, hello.
Yes, sir.
Yeah, so in this one droplet we will get only the specific like controlled molecular weight polymer, okay. That is the benefit. Then recovery of your polymeric material is easy, as we will get the polymer in beads form, okay. These two differences are there. Then again, as we are using water as a media, your heat dissipation will again in control, correct? Means whatever heat will produce during your polymerization, that will dissipate it in your water system, okay. So your heat will be in a control, correct, as is in your solution polymerization, okay. Have you understand? Hello.
Yes, sir.
Yeah. So these all are the benefits of your suspension polymerization. Here we can see the advantages and disadvantages of suspension polymerization. Okay. Advantages are like aqueous or hydrocarbon media provides good heat transfer, as we are saying water is providing good heat transfer. Then good particle size control through agitation, means if you want specific particle size of your polymer, we can control it through your agitation, or we can call it as a stirring or mixing, okay. So you can differ your, or you can change your mixing or speed of mixing. After changing, you will get the different size of your polymer or polymeric material, correct? So product is easy to recover or and transfer. As I said, your product is in bead form, so you can easily remove it from your water system, correct? These all are the advantages of your suspension polymerization. And what are all the disadvantages? Like suspending agents contaminate the product, means can contaminate the product. As now he mentioned, like the your surfactant is compatible with your monomer or not. Suppose in some case, if your surfactant is not compatible, okay, or not or somewhat reacting with your monomer, then it will contaminate your product, correct? So that's why your surfactant should be compatible, or should not be react with your monomeric system or whatever polymeric system, okay. So that is the disadvantage. And removal of residue monomer is necessary, means whatever unreacted monomers will be there in your system, that is difficult to remove, okay. These are the disadvantages. So all of you know about the suspension polymerization now. Have you understand about suspension polymerization? Hello.
Yes, sir. Understood.
Okay, so we'll move forward for next type, okay, that is emulsion polymerization, okay. So before that, can we take break of only 5 minutes?
Yes, sir.
Okay, so we'll take break, and again we'll meet after 5 minutes, okay. Okay. Hello. 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 Am I audible
Yes,
to all
sir.
of you? Yeah.
Yes, sir.
So we'll restart our lecture. Okay. So till now we learned about three techniques or three methods of polymerization or okay. So first is like bulk polymerization, solution polymerization, and third is suspension polymerization. Okay. So we'll move forward for our fourth technique, which is like you can say somewhat critical or somewhat difficult technique. Okay. So which we called it as a emulsion polymerization. Okay. So can you tell me like in solution polymerization we said like only water insoluble monomers we can use, correct? We have to water system, okay, and in that water we have to water insoluble monomers, correct? Yes or no? Hello.
In suspension, we do water insoluble.
In suspension polymerization we took water insoluble monomer, correct? Yes. So what means how we will synthesize water soluble monomers then? Is there any technique or can we synthesize water soluble monomer with the help of suspension? Okay. So for such a kind of reactions, we require emulsion polymerization techniques. Okay. So what is emulsion polymerization basically? Okay, so we'll take a simple example of emulsion. As we took suspensions example, like what in water we will add some oil, and if you mix it, we will get some suspended droplets over it. Correct. So for emulsion also we are having one example. Do you know about the milk? Hello.
Yeah, yes, yes.
Yeah, milk is nothing but a emulsion. Okay. How we can call it as a emulsion? Yeah, milk is a emulsion, but how it is emulsion? Okay, so do you know how they separated the fat from your milk? Do you know there is a presence of fat in milk? Hello.
Yes, sir. Malai.
Yeah, malai we can say it as a, but that we can get after heating the milk only. But do you know how we can get fat out of it? Means whatever dairy milk dairies are there, they calculate the fat present in your milk. Okay, so in that case, what they usually do, they will centrifuge or some of the method, they settle down the particles or fat from your milk. Okay, so your milk will get separated into two parts. One is the fat and one is your water. Milk is nothing but the emulsion of your fat in water. Okay. Hello.
Yeah, yes, sir, understood.
Yeah, milk is nothing but there is a presence of fat particles, or you can say a bundle of fats in your water, which is perfectly dispersed in water. That's why we got the color of milk, whitish color of milk. Correct? We can't observe it by naked eyes. Okay, but it is having suspended form, or we can call it as a emulsion form. Okay, so milk is the perfect example of your emulsion system. Okay, so again I will we will go through it. Okay, so what is emulsion polymerization? Emulsion polymerization is a type of radical polymerization that usually starts with an emulsion incorporating in water, monomer, and surfactant. So what all requirements are there in emulsion polymerization? Again, as usual, monomer and initiator should be there. Correct? For all of these techniques, the basic requirement is your monomer and initiator. Okay, so here additionally water and surfactant is there, as we have already seen in your suspension polymerization. Correct. Hello.
Yes, sir.
Okay. So here what is the other requirements are there? The most common type of emulsion polymerization is an oil in water emulsions. Okay. So why it is called is as a oil in water? So see, there are many again types of emulsion polymerization are there. Oil in water or water in oil. What is difference between these both? Oil in water and water in oil. Is there any difference? Yes. Can you say that there is a difference between these both?
No, both, no, we cannot say both are almost same.
Yeah, there is difference. Okay. Whatever we took in your suspension polymerization is we took what your monomers in your water system. Correct? So your water is more in that case. Correct? That's why you are able to form droplets in your water. Correct? Oil or monomer droplets in your water. Correct? So
Okay.
similar thing here we can apply. Oil in water means your water is in a bulk form, or you can say in a more quantity. Okay, that's why we will get here oil in water emulsion. Okay, and second is like water in oil. What will be in that case? Oil in your bulk form or in more quantity. Correct? Hello.
Yes, sir.
Yeah, these two basic differences are there. Okay, so in that case what will happen if you have monomers which are soluble in water? Correct? Monomers which are soluble in water. In that case what you
Okay.
will do, you will take oil in bulk form, and in that you are going to suspend your monomers by mixing it in water, or you can say water droplets. So your water will form droplets in your oil. So we can call it as a water in oil emulsion. Correct?
So this is almost similar to a paint.
Yeah, it is we can say most of the things are similar to your suspension polymerization.
No,
Okay.
no, this house painting we are doing, no?
Yes.
It's looking very similar to that one. Some chemical we are purchasing and adding water to that, and we are doing painting. So is
Yeah,
a
yeah. It is nothing but redispersible powder. Okay.
uh,
Whatever chemicals you
there
are
also
using,
we
that
call
will
it
be in a
as
powder form.
emulsifier.
Correct?
Emulsion only it is
Yeah,
told.
emulsion only. If you add it in water, it will form some emulsion, and that emulsion you can directly paint.
Yeah, yes.
That you are saying, no? That is
Yeah,
nothing
paint
but the
also we call
product
it as
formed by
emulsion.
emulsion polymerization.
So that every day we are doing like it's like practically we are doing that polymerization only. Yeah.
Yeah, it is already synthesized polymer you are having.
Okay. Paint is a
You are
synthetic.
not doing polymerization.
Okay.
You are directly taking the synthesized polymer. You are dispersing it in a water. Okay,
Okay.
and you are applying it.
Okay.
Okay, so what is there the requirement? The most common type of emulsion polymerization is oil in water, as we have already seen in your suspension case, in which droplets of monomer, or we can say the oil, here don't consider directly oil, but as it is suspended in your water, so we can consider is a oily form. Okay, so droplets of monomer are emulsified with surfactant in a continuous phase of water. Have you understand this?
Yeah, yes, sir.
Okay, it is nothing but your monomer droplets by surrounded by your surfactant structure are dispersed in your water system or water phase. Okay.
Yes, sir.
Yeah, here water soluble polymers such as certain polyvinyl alcohol or hydroxyethyl cellulose can also be used to act as a emulsifier or stabilizer. Here are the some of the examples of emulsifier have been given here. Okay, so this is the image from where you can understand the emulsion polymerization better. Okay, so what is the major difference between your emulsion polymerization and suspension polymerization? We will see here. Okay, so in suspension polymerization, in your droplets polymer will get synthesized. Correct? In suspension polymerization, here one micelle we called it as a micelle. Okay, what we called as a micelle. Okay, some I think word is missing there or not. I don't know. I will see if word is there. Okay, the word is not there, but I will write it in your chat box. Okay. Okay, so as I mentioned here, okay, mycelial formation, okay, mycelial formation will be there. See, one minute just. Okay, so can you observe this droplet over here, surrounded by your surfactant structure? Have you seen the surfactant structure over here?
Yeah, yes.
Yeah. So these tails, whatever the tails are here, are nothing but your hydrophobic end. Hydrophobic end means your oil loving, correct? And this is head is nothing but hydrophilic end, which are water loving, correct?
Okay.
So in this case, the requirement means how it is different from your suspension polymerization. In your suspension polymerization, your monomer and your initiator both are soluble in oil phase, correct? If you consider this bigger one droplet here, so if you consider suspension polymerization, in suspension polymerization, your monomer as well as initiator are in a oil phase, correct?
Yes, sir.
Okay, but in emulsion polymerization, only your monomer is in oil phase. Whatever droplet you are looking here is nothing but your, it consists of your monomers. Okay, this droplet is nothing but a number of monomers present here, but your initiator is soluble in your water. Okay, you can see here initiator radical or initiator, which you can see here. Can you see?
It's like electrolytes in plating shop, plating.
Yeah, it's like a radical or electrolytes, or you can say cationic or anionic, but mainly radicals are or free radicals are used for emulsion polymerization. So here you can see the radicals, initiator radicals over here, which are soluble in your water, correct?
Yeah, yes, sir.
Yeah. So this is the major difference between your suspension and emulsion polymerization. Your monomers are in oily phase and your initiator radicals in water phase. Okay. So how your polymerization will get start? Okay. Suppose these have you seen this red color cursor?
Yeah, yes, visible.
Okay. Suppose this red color you can consider as a free radical. Okay, which is present in water. Okay, so it will start your polymerization at the surface of your micelle. This is nothing but we can call it as a micelle. Okay, this droplet we can call it as a micelle. Okay, so after penetrating through this micelle surface, this initiator will start your polymerization. Have you understand?
The
Hello?
free radical will go in between.
Yeah, not go in between. It will start the polymerization from the surface only. It will reach
Surface
the
of
surface.
monomers.
Yeah,
Surface of the
surface of the
insoluble
monomeric
monomers.
system. This is not a single monomer. This is monomeric system. Okay, many
Okay.
monomers are present over there. Okay, so it will penetrate this surface. Okay, so it will start your polymerization from here. Means whatever first monomer is towards your surface from inside, it will that initiator will attack that monomer. Okay, and that monomer will get start your polymerization over this droplet. Okay,
Okay.
have you understand this?
Yes, sir. Yes, sir.
So in this way your polymerization in your suspension polymerization will get start. Okay,
Yes.
okay, so in this case also you will get the polymer in powder form. What? Powder form. Do you know any polymer, or do you see, have you seen any polymer in powder form? Hello?
Chlorides.
Yes,
Chlorides.
chlorine.
Yeah, chlorine.
Chlorine means you can say like PVC, polyvinyl chloride, correct?
Okay. PVC.
So PVC, whatever pipes and all things we made out of PVC, that PVC plastic you will get in a powder form. Okay, so that we can get using suspension as well as emulsion polymerization. Means whatever product you will get from suspension will be in your bead form or powder form. Okay, and also in this case emulsion polymerization you will get your polymer in powder form. Okay, but the case is like difference is whatever the particle size of your polymer, you will get minimum particle size out of your emulsion polymerization. If you want your polymers in micro level, okay, here you can observe here 40 angstrom, or in that way, in that range you will get. Okay, hello.
Yes, sir.
Yeah, so at micro level powder you can get from your emulsion polymerization. Okay, so have you understand about emulsion polymerization?
Yes, sir.
So what all requirements for emulsion polymerization are there?
Sir, one thing that monomer droplet you are saying, no?
Yes,
That monomer droplet by picture it is very big. From the monomer droplet, some portion will get disintegrated as pink color.
yes.
It's like that. From there, there
Yeah,
will be
it is not,
disintegration.
it is only for representation only. Okay.
No. For understanding also, I'm asking.
Yeah.
Monomer can be of different size, or it will be only with some
See,
8 or
whatever
10
monomers you are using, monomers are of
combination, or
same
it will
size.
be uniform.
But yeah, monomers are of same size, but you are having bunch of monomers. Correct? Monomer
That
droplet.
is a,
You can consider, if you are consider a single droplet of monomers, what it consists of? The
okay.
droplet will consist of 100 or 200 or 300 monomers in it. Okay.
So
Suppose
monomer
if
droplet
you
can
are,
differ.
yes.
Monomer droplets can differ in this case.
No,
Stirring,
monomer
stirring and
droplet
other
means
things
size
are
of
not there.
droplet will differ, not monomers. Okay, let's take one example. Okay, if you are having water droplet, correct? What is water? Nothing but H2O, correct?
Okay.
Okay, so in one water droplet, how many H2O will be there? Can you
It will
see?
be plenty of H2O.
Huh?
Plenty of H2O will be there.
Plenty of H2O will be there, correct? If you are considering two water droplets, can you tell that in first of my water droplet there are 1000 H2O, and second in
Last time in the this thing another polymerization we saw, suspension polymerization was having a stirrer where uniformity of this thing will happen. That is
Yes,
what you told in
that
the
uniformity,
representation.
that uniformity is dependent of your concentration of surfactant, first of all, then your stirring rate, or you can say mixing rate.
In this case,
Okay.
stirrer will not be
In
there.
this case also stirring is there. Stirring is important here as well. Okay, but then also you will have some difference between your droplet size, because perfectly as only one size droplets you will not get, but at least suppose if you are getting 2 micrometer droplet, then second will be like 2.1, or first will be like 1.8, in that way, nearly same, but somewhat difference will be there. This is only for, this representation is only for your understanding. Like after zooming out the micelle structure, you will see this kind of structure, and if you again want to see it in a smaller form, you will see this kind of structure. That
And last time what we understand from this radicals, only radicals will work with the end case. When all the combinations are over, then the left out radicals will try to get engaged to stabilize.
yes,
Then
yes,
there will not be further reaction.
yes,
So here also these radicals
yes,
will wait for the
yes,
complete
yes,
reaction to happen,
yes,
and
yes,
last it will come and suspend it, or the chain
This,
reaction will
this case
continue?
also, as it is a type of these are the methods of polymerization, but you can use that polymerization technique over here, okay, like to terminate the chains you are talking about, correct?
Yeah, yes.
Yeah, in this case also you can say like that, but in this many of the polymeric chains are not terminated, okay, as it is in the form of emulsion, but while forming it in a powder form or in a, you can say that uh, end form, you will get the terminated chain as well as free end chain polymerization. It depends on what you want. If you want it to get terminated, we can add some like chain transfer agent or like that materials in it to terminate the chains, okay, that will help you to complete your polymeric chain, okay.
Okay, sir. Okay.
Okay, have you understand emulsion polymerization?
Yeah, yes, sir.
Okay,
Then what is
so
the 40A and 50A?
that is nothing but the size. It is just a general representation that whatever micelle structure will be formed in between the emulsion polymerization can be reduced till, means minimum size we can get through emulsion polymerization of your polymer, means very fine polymeric particles we can synthesize using emulsion polymerization,
Okay.
okay. So this all is about the emulsion polymerization. Now we will see the advantages of emulsion polymerization. Okay, what all advantages are there? Like high molecular weight polymers can be made at fast polymerization rates. By contrast, in bulk and solution free radical polymerization. Okay, then the continuous water phase is an excellent conductor of heat, as we already seen in our suspension polymerization. Means whatever heat will generate during polymerization, it will capture by your water or dissipate by your water, correct?
Yes, sir.
Okay. Again, some of the advantages like minimum size of polymeric structure you can achieve from emulsion polymerization, okay. Then separation of polymeric droplets or polymeric particles can be means can be easy for your emulsion polymerization, okay. So what all differences are there? For dry or dry polymers, water removal is an energy intensive process. Like whenever you are separating it, so separating it from water is require more energy. Okay. Then second is like emulsion polymers are usually designed to operate at high conversion of your monomer to polymer. Okay. This can result in significant chain transfer to polymer. As you have mentioned here in your last doubt, like can the polymers get transferred to the next chain? So that is somewhat difficult in this case. That's why we want to add transfer or chain transfer agents, okay. So same advantage and disadvantage you can observe here, okay. Then these are the four types I have mentioned here which we learned today. First is like one, second is solution, third is suspension, and fourth is emulsion, correct? Okay, so these are the main advantages and disadvantages I have mentioned here for your understanding and for comparison purpose, okay. Have you observed last type, inverse emulsion? I have mentioned here. Hello. Hello.
Yes, sir.
Yeah. I have mentioned fifth row over there. Which is nothing but your inverse emulsion. Okay. Why it is so? Can you tell? Okay. So let's discuss like what what is there in emulsion we have seen now. It is in oil in water system is there, correct? So if we inverse the case, like I have already told you, if you want to take water in oil, okay, if I suppose want to take water in oil emulsion, So that we called it as a inverse emulsion. Okay. Hello.
Yes, sir.
Hello. You understand?
Yes, sir.
Okay. So these are the main 4 techniques by which we can synthesize your polymer. Okay. Do you have any doubt in this? Hello.
Sir, you said that the last tell about
Sir,
purpose of all these things or application where it is being used.
Okay, correct. So let's see about it. See, we have seen like bulk, solution, suspension, and emulsion polymerization here. Okay, so whatever kind of like, suppose some of the application is needed like product in bulk form, or you can say like directly the you know, like if you are having suppose wheat flour, out of wheat flour we make dough to make chapatis, correct? So if you want product in dough form, so you will use bulk polymerization in that case, correct? Okay. So if you want your polymer in solution form, okay, if you want to cast some film, or do you know the casting? Hello.
Ah, yes, yes.
Yeah, do you know the casting? Like suppose some mold is there and you want to add some polymeric solution over it. Okay, in that case you can use the solution polymerization, and even it's not like that only the solution polymerization is in that case, but solution polymerization is generally used to control the molecular weight of your polymer. If you suppose like control molecular weight you required, okay, then your bulk, then you are using solution polymerization. Then again, if you want more specific molecular weight polymer, then then people generally do the suspension or emulsion polymerization, because in suspension and emulsion polymerization you will get the controlled molecular weight products or controlled molecular weight polymer. Okay, so that's why these 4 kind of polymerizations are divided into or divided in such a class of techniques. Okay,
So
suppose
in
suppose someone,
casting,
yeah, suppose someone want polymer in powder form. Okay, suppose some application needed your polymer in powder form, then what technique you can use? You can use suspension or emulsion polymerization. In again that also, if you want finer particle size of your polymer, very fine, you can say in a micro level, so you will definitely use your emulsion polymerization technique.
bulk powder required na, you told bulk polymer, no, sir?
Yeah, bulk you will get polymer in the form of like mass form or single, you can say dove form, that you can again, if you crush it, you will get it in a bead or in that form.
Okay, it will be like
It is a
slugs.
single mass form. You
It is like slug,
after polymerization, you will get a single mass out of it.
single mass with a bigger size.
Yeah, whatever means whatever size you have polymerized.
Okay. From
Okay,
there,
that
process
again you
we
can
have to crush
that
it
again
and
you can
mechanically you have to do.
yes, that again you can crush it if you want finer product.
Okay.
Okay, but in emulsion you will get finer particle size of your polymer.
So directly we can get finer particles.
Yeah,
Beach form means pearl form is
yeah,
suspended.
yeah. Beads is
And
nothing but your
again,
pearl.
in between these two size will be solution polymer.
Yeah, solution polymer.
So, but
In solution as well, after removing the solvent, you will get the product in your bulk form only, but the molecular weight is in control as compared to your bulk polymerization. Okay, and
okay.
again, as we
Lower,
see the heat dissipation and all that benefits are there.
the lower molecular weight in solution polymers, suspension polymer, we will get higher molecular weight.
Yes, yes, but controlled molecular weight, higher but controlled.
Controlled also. The
Yeah,
consistency will be good. Huh?
yeah, yeah. Consistency will be good.
Okay. In emulsion also we will get consistency, you know.
Yeah, yeah, yeah. In emulsion also.
Higher molecular weight will be there and the consistency
Yes,
will be there.
yes, yes.
What inverse emulsion law?
Yeah, now only I told you, like when at the start of emulsion polymerization, we are having two types like oil in water and water in oil, correct?
Okay.
So we have took example of what oil in water type of emulsion, correct? Here you have seen oil in your water system. Okay. If
Okay.
you inverse that thing as water in oil, okay. If you take water in oil, then we can call it as a inverse emulsion,
Okay.
correct? In that case, what will happen? Your monomer should be water soluble, correct?
Okay.
Yeah. So these things are clear for
Uh,
you.
Here there is no relation with molecular weight or size and shape. What will be the output?
Out of these four techniques you are asking about,
Last inverse emulsion.
inverse that see there is only one difference is there. See, in suspension, you are requiring water soluble monomers, correct?
Okay.
But all of your monomers are not only water soluble. Oh, sorry, water insoluble. Correct. In
Yeah.
suspension, you require water insoluble monomer, correct?
Yeah. Yes.
Yeah. But if you are having water soluble monomer, then what you will do?
We have to
So
go.
you will follow the emulsion polymerization technique. In that, what will happen if you use inverse emulsion? Then you will take water droplets in your oil media, correct?
Okay.
Yes. So you can use water soluble as well as water insoluble monomers in emulsion technique.
No. Emulsion both the water soluble and insoluble will be there. Huh?
Yeah.
Then
If you
inverse.
are if
In inverse.
yeah, that's I'm telling na. Emulsion, see, if you can divide in emulsion, water in oil and oil in water, these two types are there, correct?
Okay.
Water in oil is nothing but inverse emulsion,
Okay.
correct?
Yes.
Are you clear about that?
Yeah. Yes.
Yeah.
But it is a soluble only, water soluble only. But
Yeah. In second technique, water soluble monomers can be used. In first technique, oil soluble monomers can be used.
okay. First one it is oil soluble and second one it is water
Yeah.
soluble.
Or you can say not like soluble, but monomers in form of oil or oily form monomer, correct? In second, water soluble. Okay.
Okay.
Yeah, that is the difference.
Okay, sir. Okay, understood.
Okay. So all of you are now clear about the polymerization techniques which we learned today.
Yes.
Okay, that's great. So here now we have finished up with all polymerization techniques, polymerization methods, like from yesterday's start of yesterday's lecture, how your polymer will get made out of your monomers, then the techniques which we are used to make polymer, we learned it today, correct? So all your polymerization part will get over here, okay? Have any, yes,
Yesterday we talked about Eastering, then that
hello,
urethane,
urethane,
that
yes,
is one type. Are all
yes.
the things applied here?
Yeah, these
Is there any
things,
particular
see,
means I have to go here?
yeah, depending on your polymer, type of polymer, okay, these things can be applied over here. See, whatever polyester, polyurethane, polyamide you have seen over there, that can be synthesized using your bulk solution polymerization, okay? Whatever PVC, polyvinyl chloride, or
Okay. Amide
you
means
can, yes, hello,
amide.
hello, your voice is breaking. You are asking about polyamide. Hello,
This is
hello,
polyamide.
yes,
Yes, sir. Can you hear me?
yeah, now I can hear.
Internet is having some problem. Now it is clear.
Yeah,
Can you hear me, sir?
yeah, I'm hearing.
Yeah, you told yesterday that amide is one of this thing, polymerization, and then Eastering is one type of polymerization, And
Yes.
then urethane is one type of polymerization.
Yes.
So amide, maybe amide, to my knowledge, it is a insoluble monomer. So it comes in first fora.
Yeah, see, in
And
that
PVC
case,
will be in the last one.
whatever the yesterday's like condensation polymerization, examples of condensation polymerization we have two, that both the examples generally means majorly made from bulk or solution polymerization. Okay.
Okay.
Yeah, means mainly these two techniques are being used for synthesizing your polyamide, polyurethane, and polyesters. Okay. Some
Okay.
of the polyesters, if you can see, polyesters can be made out of your suspension polymerization. Means suspension and emulsion polymerization also can be used, but majorly bulk and solution polymerization are their use. Okay. Like if you take the
Okay.
example of polyethylene, okay, so polyethylene, or you can take the example of polystyrene, suppose. So polystyrene can be made out of these four, all of four methods can be used for polystyrene synthesis. Okay, but depending upon the application of polystyrene, we can change the polymerization method. Okay.
Okay.
Yeah. Any other doubts? Okay, so if you are not having any doubts, so I can think that you have understood the things from yesterday's lecture to today. Okay, so next will be our structure property relationship lecture will be there. So in that we will learn about the how your polymeric structure will behave accordingly. It's how that structure will get the properties, means different properties like thermal, mechanical, or you can say rheological properties or viscosity properties or whatever you mentioned, density and all. How that all properties will get differ. Hello. Hello.
Yeah,
Yeah.
sir.
So how that properties will get differ by your structure, by modifying your structure or different polymeric structure. So that thing we will learn in our next
Sir,
lecture.
sorry to disturb you. Is tomorrow class is there?
I think tomorrow class is not there, but you can confirm it again with your coordinator. Okay.
Because today some urgent meeting, so I just log in, but I didn't attended the class.
Yeah. So you can ask to your colleagues as well
Sure,
here
sir.
also in
Thank you.
chat or
Tomorrow
that
is
way.
closed. Sorry to disturb you. Tomorrow and next class is 14th onwards because Navratri is there. So no
Yeah.
one can attend the class last batch. That is why we have decided to keep the closed
great.
classes on Navratri.
Okay, from which 14th onwards, right?
Yeah, yeah. It is started on 14, commencing from 14 onwards.
And one more thing, that daily recorded session, can we get a daily basis?
We already share it to every day.
Okay. Thank you. Because sometime due to meeting we are doing login,
Yeah.
and we are not available. Okay, thank you.
Sir, during these holidays, you can share any of the questions like previous years.
Sure.
Uh,
Definitely. I'll
And
create
sir,
a WhatsApp group
all
also.
PDFs, sir, we are waiting, sir, all PDFs. Yeah.
Okay.
Yeah.
Maybe,
PPTs,
sir, one more thing, maybe assignments, maybe we can do at home if something is there.
Okay. Whole question paper we'll definitely share with you.
Thank you, sir.
yeah, thank you.
Okay. So we'll meet at 14. Okay. With next topic. Okay.
Yes, sir. Thank you, sir.
Yeah. Okay. Thank you.
Thank you, sir.